Here we have a problem on logarithm. Let's read the question. Find logarithm of 64 to the base 2 root 2. That is, we have to find the value of log 64 to the base root 2. Okay, to find the value of this logarithm, what I have to do is I have to write this 64 in terms of 2 root 2, in terms of exponent of 2 root 2, which is in base. So once I get the value 64 in terms of exponent of 2 root 2, I can easily get the value of log 64 to the base 2 root 2. Okay, so to get 64 in terms of exponent of 2 root 2, I'm just going to decompose 64 by 2. So then I get, it's an even number 64, I divide it by 2, I get 32, again I divide it by 2, I get 16, again I divide this one by 2, I get 8, again I divide this by 2, I get 4, again I divide this by 2, I get 2. So I get 64 is equal to 2 to the power of 6. Okay, I got 64 in terms of exponent of 2, but I need 64 in terms of exponent of 2 root 2. I need two 2's, the first 2 without square root, the second 2 with square root. Okay, for a trial, I am going to split the exponent 6 as 3 plus 3. Okay, in the next step, and further, we can split this 2 to the power of 3 plus 3 as 2 to the power of 3 times 2 to the power of 3. Okay, I got two 2's. So for both the 2's, we don't have square root. For one of the 2's, we need square root. So what do we have to do? Let's look at here. So let me take the 2. For this 2, I need square root. So I can take it, but to adjust the square root, what I need to do is I have to square. So then only the value will not be changed. So even if I simplify this one, I'll be getting 2. So whenever we need square root for a number which is not having, what we need to do is we can take square root, but to adjust the square root, we have to square. So instead of 2, we can write square root of 2 the whole square. So 2 to the power of 3 times square root of 2 whole square. For this 2, we can write square root of 2 the whole square. Already there is exponent 3, so we can take the same. So 2 to the power of 3 times square root of 2. Now we can multiply these two exponents. So when I multiply those two exponents, so 2 times 3 is 6. So square root of 2 whole to the power of 6. Here, for this 2, we have the exponent 3. For this square root of 2, we have exponent 6. We don't have the common exponent. Only if you have the common exponent, the same exponent for both 2 and square root of 2, we'll be able to write the value in terms of exponent of 2 root 2. So I have splitted the 6 here as 3 plus 3. So splitting 6 as 3 plus 3 doesn't work. Okay, let's try it in some other way. That is, instead of splitting 6 as 3 plus 3, better we can split 6 as 4 plus 2. So in the next step, we will get 2 to the power of 4 times 2 to the power of 2. And then 2 to the power of 4. Instead of this 2, we can take square root of 2 the whole square. And there is 2 exponent here, the same should be taken. So 2 to the power of 4 times, so these two exponents can be multiplied, then we get square root of 2 whole to the power of 4. Okay, now we got the same exponent for 2 and also square root of 2. So because we have the same exponent for both 2 and square root of 2, we can take the exponent 4 in common, then we'll get 2 times square root of 2 whole to the power of 4. So 64 is equal to 2 times square root of 2 whole to the power of 4. So log, instead of this 64, we can write 2 times square root of 2 whole to the power of 4 to the base 2 times square root of 2. Okay, according to the third fundamental law of logarithm, what we can do is we can take this exponent 4 in front of the logarithm, then 4 times log 2 times square root of 2 to the base 2 times square root of 2. Here the base and argument both are equal, so the value of this logarithm is 1. So 4 times 1 is equal to 4. So the logarithm of 64 to the base 2 square root of 2 is 4.